Yeah, good everyone. Rick is my name, and right here I'm presenting my project for Consensys Bootcamp 2021. And for the purpose of the bootcamp, I worked on what I call DAZA, and DAZA basically stands for Decentralized Afro-Zoned Addresses. So DAZA is a DEX that allows individuals to perform the basic functionalities of swapping, ramping fiat, and also liquidity provisioning, and also staking and all of that. But just for the context of this project, I did explore some key features, which are the swap functions and the liquidity provisioning. So let's dive straight up into it. So to run this project, which is just starting out, we would have to start up an Ethereum client, and for that I used Ganache CLI. And Ganache CLI, again, I think it's obvious if you're through the bootcamp, but Ganache CLI is basically just like a mini version of the Ethereum blockchain network that you can run locally to be able to perform transactions. So that said, first off, you want to start up the client. Then next up, you want to more or less compile the contract using the command Truffle migrate. So okay, that compiles okay successfully. So as you can see now on compilation, we have DAZA DEX and also have DAZA token, and that's because for the purpose of this DEX, we incorporated a native token that allowed us just explore the basic functionalities of the DEX we wanted to get tested out and know. So once this is done, you want to go into your public directory, then JS and abi.ca, and you more or less locate the contract address for the token, and you replace this, and you locate the contract address for the DEX too. The DEX is like a decentralized exchange, and you replace this. Then more importantly, you want to locate the deploy private key, and that by default Ganache uses the first account to deploy contracts. But again, if you want to specify a special account to use for deployment, you can do that here. But you will also require to locate the private key and include it in this file. But that's just for the purpose of reinitializing the DEX, because for the deployed version that's live on Heroku, you do not need to go through all of the steps. So that said, you have this contract address, the token address. So once it's saved, we can now move on to start our DEX. Let's run it on the live server for the purpose of this. So now our DEX is running, and you can see all these are just placeholders to show that okay, we have not started interacting with the DEX, but we have the swap functionality and the liquidity provisioning functionality. So next up, you want to import a new account through which you'll be interacting with this, and it's important you do not import the first account. You can pick any other one. As you can see, you have like 10 accounts, so you can pick any one and import that to use along with the DEX. So we just do import and put this. So yeah, so we have 100 ads testers through which you can interact with the DEX. So first up, connect our wallet, connect, next, connect. You notice it pop up immediately. So what is really going on is our DEX has gone on to credit us with 300 DAZA, which is a native token. You see that in a minute. Make it connect, you get credited with the native token 300 units, and you approve the DEX to be able to spend certain amount. That's about 200 units of your DAZA token. And so you can see our head balance moved because of the contract interaction, and we have our DAZA token. So let's jump right on into the DEX now. So imagine you want to swap some ETH for DAZA. First off, we want to look at our current balance now. I have 99.9 this, and I have 300 DAZA. So I want to swap some of my ETH. Let me just say like 0.1 ETH I want to swap that for some DAZA. So I click the swap function, and again it interacts with the contract. And what you can see now, how liquidity on the DEX moved. We now have 1.1 ETH reserve, and our DAZA balance reduced by corresponding amount. The price got updated, and if you go to our wallet now, you should be able to see our ETH balance has reduced by 0.1, and our DAZA balance has increased by the corresponding amount. So the same way you can swap to ETH, you can also swap from DAZA to ETH. Let me see, I'm doing like 10 DAZA to ETH swap. Okay, it says entire smaller amount and no. Okay, this occurs whenever because what's really going on here is there's a kind of calculation based on the current price, and it's interacting to see if we have enough ETH balance to again meet up with the amount of DAZA I want to swap. So let's do a smaller amount. Let's just say like let's do 1. So 1 should be fine. So I want to swap 1 DAZA for each. Again, you can see it initiates the contract interaction, and it swaps 1. You can see our balance increases here, reduces here. That's for the exchange reserve, and the liquidity, what we have in our balance. Again, you can see it moves like by the amount of units and all. So that's for the swap function. Then for the liquidity provisioning, you can add some liquidity to the DEX. Let's say I want to add like 0.1 worth of liquidity. What happens when you provision liquidity is you're not just adding ETH balance, but you're also adding DAZA equivalent for that ETH amount. So you can see this, both balances are updated. I can do it once again, just so you see, and see it updates them together. So that's about that. So, but again, for the remove liquidity functionalities, I was very intentional not to allow just any individual remove liquidity, because since the DEX is still just more or less like a basic iteration of what we want to achieve, I do not want anyone draining the liquidity that exists on the live platform. This is a live platform running on Iroko. Okay, so as you can see, I successfully interacted with it, and I could also do the same with the live